Welcome back. This is an Aleks homework video on using K sub f to calculate the equilibrium molarity of a complex. Well, I hope you're not watching this video because if you are, it means you've been assigned this problem, and I would have to give this one, hands down, that this is the hardest Aleks problem I've ever done. So thank you, Aleks, for a whole afternoon of trying to figure out this problem. But I think I got it, and I'll try to explain it to you as best I can. All right. So first of all, a complex is not really a compound. It's essentially where a metal is hanging on to something not really with a full bond, but almost like holding hands with something. And so an entire molecule can be connected to a metal at various places. So in this case, you're trying to form the complex, a nickel complex with ammonia. And you can see that the nickel is holding on to 6 ammonias and making a big complex. Well, in order to do that, it's actually going to have to go through a water complex first. All right, so, and Aleks didn't tell you this, so here's the first thing that I would say. So I have a complex made with water in order to make the complex made with the ammonia. All right, so they're going to give you nickel nitrate. Well, nickel nitrate is a salt, and if you were to put nickel nitrate in water, nitrate is soluble in water, and it simply will just dissolve and leave you that nickel, probably 2 cation. And so once you have that nickel 2 cation, it is going to complex with the water that it's in. So that's the first thing that you need. And it doesn't matter what you're given. You're always going to have whatever metal that is plus 6 waters. That'll be how you start this problem. Then you have to balance the equation. So in this case, it's not so hard since you're given that you're going to need 6 ammonias in order to make a complex. You'll have to have 6 ammonias here. All right, so once you have a balanced equation, you can keep going. So here's the K sub f. It's just the products divided by the reactants. And they give you a K sub f of 5.5 times 10 to the 8. All right, so you have your K sub f. Now here's where it also gives you a headache. They told you that you have equal volumes. And if you have equal volumes, then remember molarity is moles over liters. So if you have doubled your liters since you have equal volumes, no matter what amount you're given, you've doubled that amount. So the moles of each, if you're going to do an ice table, have to be halved. So you were given the 0.0042 moles of the nickel nitrate. That means you're going to have half of that as a nickel complex with the water, 0.0021. Likewise, you have the 0.52 moles of ammonia. You're only going to have a half of that since the liquid has halved the molarity. Okay, and it's the molarity here is in brackets that you're doing. So you do the ice table the way you've been taught, and you get an absolutely awful equation here. You've got 1 part to the 6th power. I don't know how to do this problem. I never got that high in math to be able to do this. There are calculators online that you can go in and do this, but I wouldn't even have it. You can't use the quadratic because the quadratic formula only goes to the 2nd power, and this is already past there. So Aleks is making you do an approximation. Okay, and I think this is where this problem became so difficult for me because I couldn't quite understand what they were wanting me to do. All right, now I'm holding on to that 0.26 initial ammonia because I'm going to need it in a minute. So I wrote it down for you. So in my initial ice table, which I'm not going to use now, I realized that I needed half that amount of ammonia, and since they gave me 0.52, I have half of that, so it's 0.26 molar initial ammonia. Okay. Now, they're going to assume that your case of f is enormous here, okay? It's 10 to the 8th power, a ridiculous huge number. And so what that implies is that you're making lots and lots and lots of product. And so since it's such a big number, Aleks is asking you to assume that all of it is made rather than just some of it. That all of it is made, and that you are going to, it's going to go completely to product. And so they're asking you to make a new ice table with this little fantasy that they've given you, okay? And that is that you have no initial concentration of the water because it's been used up. You have the full concentration, whatever that initial water complex was, the 0.0021, is now fully made into the ammonia complex. All right, so that's where you get your first number, 0.0021. Now, the second number drove me crazy for ages. Where did they get this? And what they did is they simply went back through the balanced equation and said, for every 1 mole of nickel ammonia complex, you're getting 6 moles of ammonia. All right, so I simply took 6 times 0.0021 and subtracted it from my initial amount of ammonia, and that's where they got this, 0.2474. Okay, and I did this numerous times with different examples, and it works every time. So that's how they did it. Then they just did a normal ice table, and they got an equation, and this time the x is so small, okay, the x is so tiny that we're just going to ignore it. Okay, so instead of making you have to do a ridiculous equation, now it's a simple algebra 1 equation. So you're going to ignore that plus 6x. And we got 1.665 something times 10 to the negative 8. And they ask for 2 significant digits. So 1.7 times 10 to the negative 8. Right? I hope this really helps you. I hope you didn't get this problem. But if you did, I hope that this helped.